So what I'm going to do is I'm going to talk about actually planning and getting beam time at BioCAT and how you might go about that for kind of your next SAXS experiment. So this I'm not going to go through in detail, but these links are in the PDF, so the slides you have, so you know where to find them, our website, our contact info. We have a web page that goes through how to apply for time, kind of step by step. We have guides on how to prepare your samples for SAXS, how to design and plan experiments for SAXS. So these are all good things to take a look at. What I want to start with is kind of what I would call our preferred timeline for scheduling beam time. So as early as possible, ideally now, if you think you want to run experiments at any point, you should register as an APS user. And this is because it can take, especially for non-US citizens, it can take weeks or a month to get the registration kind of through and cleared. And this is there's nothing we can do about this. This is on the APS and the Argonne side. So if you think you're going to want to run experiments at some point, it's best to register now. And that you might have to renew the registration, but that's a little easier, and it's good for 2 years, so it'll last for a while. So then ideally kind of 2 to 3 months out, when you think you want to run an experiment, you'll contact us to talk about the proposed experiment, and you'll put in a proposal, which we call GUPs. And I'll go over that in more detail in a few slides. Kind of 1 to 2 months out, we schedule your beam time so we know what's happening. About a month out, finalize the experimental plan. You submit the ESAF, which is the safety paperwork, which I'll mention in a couple slides as well. Complete any required safety trainings so that you're good to go. 2 weeks out, you send us a spreadsheet with all your buffer and sample information. 3 days before, if you're shipping samples, you ship the samples to us. This has a little variation because we can't accept shipments on the weekends or on holidays, so you have to make sure you account for that. But the Argonne shipping department just isn't open, so there's no way for things to get on site. Then, of course, we have the beam time. For remote beam time, we don't really do a remote mode. I'll talk about that in a moment. But you should be available by phone and email for questions. If you're on site, then there's a safety orientation. We post the safety paperwork, and then you collect data. Kind of shortly after the beam time, give it a couple days because we're pretty busy. We'll make the data available on Globus for download, either if you're remote or if you're on site and you want to get it that way. You fill out a feedback form and then ideally analyze and publish your data. But we recognize a lot of experiments are iterative, so after the analysis, you might come back, refine your experiment, different conditions, different mutants, things like this, and kind of go from there. So that's the ideal timeline. Of course, we recognize that research doesn't always run on ideal timelines, so it is possible to do this in a much more compressed fashion. In this case, this is kind of the minimum time we need. So maybe 3 weeks out, you contact the beamline scientist, let us know you want time, you put in a proposal. 2 to 3 weeks before, we schedule the beam time. 2 weeks out, we finalize all the experimental stuff, complete the paperwork, complete the training, send us a list of what you want to do. Then, shipping sample, beam time, and the post proceeds as before. But while we do support these very rapid access experiments, most beam time is scheduled further in advance. We don't have a lot of available slots. So this compressed timeline is usually only for things we can kind of fit in the margins. Maybe you have 1 to 2 samples that have to be measured really soon. Data that's been requested by a paper reviewer, that last bit you need for your thesis, or for that paper submission, something like that. We try to squeeze these in. I can't guarantee, but it's a reasonable thing to ask of us. But if you come to me and say I need 24 hours of beam time for 12 or 16 samples, and it's 2 weeks before, the odds are we're not going to be able to accommodate that. So you want to kind of plan accordingly and ideally schedule further in advance. But we recognize that these kind of semi-emergencies come up, and we try to do our best to accommodate those when we can. So I want to spend a little bit of time talking about the different types of experiments that we support at BioCAT. So the main one of these that should be familiar to everybody is what we call on-site experiments. And so this is very straightforward. You just come on site. You'll be trained at the beamline in data collection analysis by a beamline scientist, Max or myself. You'll initially work collaboratively with us, probably for the first anywhere from 2 to 6 or 8 hours, depending on how familiar you are with SAXS and the beamline and things like that. Where we'll be kind of with you, collecting the data, making sure everything goes okay. And then ideally, once you're up and running and you understand the systems, you know how it works, we'll leave you on your own to collect the rest of your data throughout the night by yourself. And if anything goes wrong, we're on call. This is what we consider kind of optimal, right? You know your samples best. We know the SAXS side best, probably. So having you on site, it allows for kind of the optimal on-site preparation. We can do active feedback on the experiments. So if you see something kind of strange or unusual that you recognize is not what you're expecting, we can possibly iterate on the conditions, change the concentration, change the buffer, things like this. These are, these are experiments and not measurements. So there's room for some change and some optimization on site. And then, if you collaborate with us on the analysis, we're happy to be co-authors on papers, but it's not expected if you're coming on site and doing the work. So the main other mode of kind of experimentation that we support is what we call remote collaboration. So here, you mail your samples to the beamline. We're involved in the planning. We do all the on-site prep and measurement because you're not here. We provide you with the first analysis of the data, and then you either analyze it independently or in collaboration with us after the fact. And for these, because of the amount of effort that we put in, we would like to be co-authors on any publications. And this is not atypical. We're somewhere like 5 to 10 papers a year published from BioCAT with beamline scientist co-authors on the SAXS side, even more on the muscle side, percentage-wise. So we do some kind of, let's call it, standard mail-in. So here you mail samples to the beamline. There's ideally minimal prep involved. We just have to thaw it and then load it. We make the measurements, we send you an automated first look at the analysis, but we don't do anything ourselves. And then you analyze the data after the fact. And if we help with the analysis, we would like to be co-authors. This mode is, especially with the pandemic, become more common, but we don't necessarily encourage it because we find a lot of these mail-in experiments become remote collaborations with extensive on-site prep on our side. Things with the samples that have to be done, we'll find out once we get them here. It doesn't look good on the elution and we have to change conditions and then again, things like this. So it tends to devolve into more scientist participation. But these are the nominally available methods, and we're happy to work with you in any of them. And basically the level of our involvement is kind of the distinction between the two different mail-in modes. So as you start planning your experiment, then I want to go through the different kinds of things that we might want to think about. So first question, of course, is always, what scientific question do you want to answer? And that is important to have in mind. SAXS is not a technique that really lends itself to kind of shooting first and asking questions later. SAXS is a technique where you want to come in with ideally a well-defined kind of question that you want to come in and answer, and then we can try to answer that question with the experiment. So knowing this straight off is going to help determine whether or not SAXS is a suitable technique for what you want to do. The next question you want to ask yourself is, can you produce enough samples in sufficient volume, concentration, and purity, which we've discussed over the course of this week. And then, important considerations, as Max mentioned in his talk. How do you know the purity? Do you know how stable the samples are after purification? How are they going to get to the beamline, right? Will they go through a freeze-thaw cycle? Have you tested that in your lab? Do you know that they're stable if you do that? Are they stable on 4C for several days? Figuring out, how do I get them from my lab to the beamline is an important step. So the next question is maybe, how many samples and buffers do you have? So this is going to help us figure out how long we need for the experiments, right? And one particular thing I want to mention, especially for SAXS, right, we lose several hours at least if we have to equilibrate a column. So if you have things that are in very similar buffers, ideally you want to combine those so that you're not going to waste time changing buffers if the samples are amenable. But people often come and they'll be in like 25 millimolar HEPs and pH 7.4 and 25 millimolar tris pH 7.5 with similar salts, and usually those can be combined, not always, but usually those can be combined into the same buffer. Pick one or the other and then kind of go with it. So this is an important one to know, so we know kind of how much time we want to schedule. And the other question is, what experiments do you need, right? Is it a SAXS? Do you not need the mols? Is it SAC-mol-SAXS? Do you want to do batch mode or ion exchange or something like that? And that also helps us figure out how we schedule these. Then, of course, can you go in person or do you need a remote collaboration? So as far as the actual nuts and bolts of applying for beamtime, so the first step is registering as a user, which you have to do to submit a proposal. Then you'll submit a proposal. So you go to this website. There are two types of proposals. There's a standard general user proposal, which are called GUPs. And these are good for 2 years. We have 3 basically runs a year is what they're called. So roughly speaking, the APS is 4 months of beamtime on and then 1 month off for maintenance and other things. And so these proposals are good for 6 runs for two years. You can put multiple requests for beamtime against them. And there's a deadline for these 3 times per year. The next one is in early July. So if you were to hustle, you could just make that deadline if you want it. If you have a standard GUP already, you can just submit a beamtime request against it. And so the other type of proposal is a rapid access GUP. So these are only good for one run, one beamtime basically, and they're a rolling submission, so you can submit them at any point. But there is a disadvantage. So the standard ones, these 2-year ones, they're scored and they're allocated by the APS about a month after the deadline. Right, and if they're scored well enough, we have to assign them time. These get the top priority because it's mandated by the APS. Rapid access proposals are scheduled at the discretion of the beamline. And so if we have an oversubscription, if we have too many things through successful GUPs that have to be scheduled, we may not be able to schedule a rapid access. We usually get to most of them or all of them in a given run, but it is something to be considering is that there is a small advantage to the standard GUPs in that they end up in the required list, and then the rapid access are scheduled later. So all of this, if you go to the website, is done. You start by clicking on General User, and then you select either Standard General User, and you can see the next deadline is July 1st. You select it there, or you select Rapid Access General User, and then select the Rapid Access for the current run of interest. And so those are the 2 types of proposals in terms of applying. Kind of simultaneous with applying for beamtime, you want to discuss the project with the beamline scientists. So things that you want to maybe bring up in a discussion with us. We'll want to know what questions you're trying to answer so we can tell you if SAXS is appropriate for the system. We should be able to give you at least an initial idea of whether or not the analysis is feasible. We may also recommend that you do some other samples or constructs that will help with the analysis of interest. We'll want to discuss what types of experiments you think you want to do, and also what we recommend. If you have enough sample and how you know the sample is pure enough, and if you've done other characterization. So these are important pieces to kind of keep in mind and bring to a conversation with us. What buffer conditions you're running, we can often recommend changes based on our experience. And then, when do you want to do these experiments, and if you can come on site. And so this is not necessarily all a single conversation. This could be, an email chain over a couple of weeks. This could be a Zoom call. It could be, a couple of Zoom calls, whatever it is, right? We also have every 2 weeks we have a SAXS coffee hour, which is just kind of an hour when Max and/or I are available. You can drop in and ask some quick questions there without having to schedule another kind of meeting, which is nice. So take advantage of that as well. Generally speaking, the more communication you have in advance with the beamline staff, the more likely your experiment is to succeed. You can't just show up at the beamline with your samples and expect to get the best quality of everything. There is some communication about capabilities, about quantities, things like that, making sure that our equipment is ready and available for those types of experiments. So these are all things that we want to do in advance. So kind of the next thing that you do as you're applying for beamtime is you fill out an ESAF. So this is the experimental safety assessment form. And those of you who sent samples, you already had to send me information for the ESAF. So links are here. And I want to emphasize, if this isn't done, we can't run the samples. We're not allowed to run the samples. Similarly, if it's not approved, we can't run the samples. And so there's a hard deadline. If you want to do on-site experiments, this has to be submitted 2 weeks in advance. For mail-in 1 week, but we still recommend 2 weeks because there's often some details to sort out. And if you miss this deadline, it's not going to get approved, and we can't do the experiment. So please take this seriously and make sure it gets done. All of this ESAF requires a list of all your samples, all your buffers, everyone who's coming, and any other equipment you bring, as well as a description of kind of experimental protocol, so that they can evaluate whether or not it's safe and ensure it's run in an appropriate manner. If you're not listed on an ESAF, or if the ESAF's not approved, you can't get on site. So that's another reason to make sure this gets done. And then the ESAF will also list on your required training for each experimenter and let us know who needs to do what. And then you'll have to do that before you can come on site or run the experiment. So kind of the next phase, as you're doing the ESAF, or possibly before, is working on sample prep. So I'm not going to belabor these points, but this is just kind of a summary for you of everything Max already talked about. Do your pre-beamline characterization, make sure the sample's good, right? Single band on SDS page gels and native gels is necessary, but not sufficient, especially just an SDS page gel. Single symmetric peaks on SEC is ideal. No visible particulates or precipitates. If you can, do sec mols or AUC, so you know really what's in it, ideally, or something similar, native mass spec. DLS can sometimes reveal the presence of large aggregates if you can't access these other techniques. And test your shipping conditions, right? Do a freeze thaw cycle if that's what it's going to go through to get the beamline. Run it on your SEC after that and make sure it looks good. And then provide us with enough sample concentration and volume. I've relisted these here. And we actually recommend you provide 2 times the volume if you can. So that way if something goes wrong, like the beam going down, we can load it again when the beam is back up and try it again. Fortunately, during the data collection for the workshop, I think we lost 1 sample to a beam down. And we went down right before the elution peak came out. It was down for about 4 hours. And at that point, we decided the elution wasn't trustworthy.
Yeah, that's right.
And we had 1 sample where it went down right after the peak was coming out. We lost a little bit of the trailing edge. So this is unusually unstable. This run, they're having some issues, but this is something to be concerned about. And so, if you only have enough for 1 run, we cross our fingers. Usually it works 95% of the time or more, but if you can, give us 2x. Other considerations, buffer choice, what's your pH range? Is it a temperature stable buffer? We prefer non-radical scavenging buffers like PBS. If you can, salt's recommended to avoid interparticle interactions and kind of modest concentrations ideally. Include glycerol or reducing agents or other scavengers only if you need them for sample stability, and consider the lifetime of the reducing agents and make sure we're adding them appropriately. Don't ship us a buffer with DTT a week before your experiment and expect it to be good. At that point, we want to add it separately right before the experiment. But of course, these are recommendations. You want to default to a buffer in which your sample is stable. And these are if you have the option, these are the considerations to apply. Send us enough volume. Usually people will ship at 5 or 10x. We'll dilute on site. All buffers have to be filtered. 0.2 for SAXS, 0.1 for second-mol SAXS. Anything that we dilute at the beamline, we will refilter. As far as shipping samples goes, we provide 4C -20 -80, so you can ship us whatever, whenever. We'll store it. Anything at the end of the run, we'll discard. We don't guarantee to keep it, so it's not a long-term storage facility. You can find shipping information here. We want disposable shippers. Cardboard box and styrofoam cooler, for example, is the most common approach. This is all on the shipping page. I'm going to kind of skip through this, but FedEx priority overnight if you want it to arrive the next morning. If not, it'll arrive in the afternoon or possibly the next day. And even this sometimes has issues, as one of our participants learned in the workshop and got stuck somewhere in North Carolina for a day, but there's nothing we can do about that. I already mentioned the weekend thing. So before you ship the samples, maybe I should swap the order of these slides. We'll send you this sample and buffer spreadsheet. And so this is something we want at least a week before you mail the samples, ideally. And it's a list of all the kind of samples and experimental conditions that you intend to run. And so by sending this to us early, we can help you iterate on it. We can say, okay, maybe that's not the right choice of column, or not enough concentration, or your buffer is a little strange. And so this gives us a chance to kind of catch obvious issues before the beam time starts and make sure that everything's ready to go when you get here. Also lets us make sure that our equipment is kind of set up and ready for the start of your beam time, so we minimize the amount of setup time needed because we know what you want to do. during and after the beam time, kind of gone through this, but on-site users, there's an orientation of safety stuff, and train you in the data collection. We'll collaborate with you as needed. Remote, just be available. We'll contact you if you see something unusual or there's decisions that we need to make that require input on the, the sample side. We'll transfer data usually over Globus, so if you're on site, you can bring an external hard drive. And then as was mentioned in the publication talk, once you actually get to publishing this, we need to include the acknowledgements for our facility. This is how we show the NIH for being productive and how they justify funding us. So if you want to keep collecting data, it's a very important thing to do. And so with that, I'm going to stop. I'm happy to take any questions on that.